So hello again, welcome to videos for Shaughnessy's class, Math 30-2. Keeping in mind all of the things and the standard disclaimer, please show up to class. Class has a variety of more examples and a variety of more explanation that's happening. This one here is Exponents and Logs, Lesson 3. This is talking about some basic exponential functions, or exponential equations, sorry. And going through and solving them with a common base. So continuing on, where it starts is this. Okay. Now before I do any of this, I just need to remind you of some common exponents, some common powers that really you should kind of recognize. You won't have them memorized, or you don't need to have them memorized, I guess. Powers of 2 are 2, 4, 8, 16, 32, 64, 128, 256, or so on. Powers of 3 are 3, 9, 27, 81, 243, 729, 2187. The powers of 5 and the powers of 6. Now the reason I point those out is because if a large number is a power of something else, really truly you have the choice. You can put either one in that spot because it is technically the same. I can say 2 cubed is 8, okay? And so I'm allowed to do that. Now, the reason I point those things out, and I'm just using that idea, is an exponential function. Exponential equation. What am I trying to do? Now this would be an exponential equation. 3 to the power of x plus 1 equals 27 to the power of x. Now that's an exponential equation. Okay, that's 3. Because the exponents, the x, the variables, the unknowns, however you want to look at it, they are in the exponent portion of this equation. It's still an equation. I still know such and such equals such and such. But I've got x's in the variables. Now there are thousands of these types, okay? But truly where I'm starting with are some of these simpler ones. These ones here don't require any great mathematics. They just require some logic, and so you guys are good. If they're a common base. Now, how are you going to recognize that? You're going to recognize that from the list. Somewhere along the line, you're going to be like, Shaughnessy gave me this list. I need to remember this list. I wish I could remember. And when you look at an exponential equation, you say, I got to solve one of these. But somewhere in your mind, I hope there's a little trick that says, hey, 3, 27. Hey, I know those. Those are both powers of 3 somehow. Okay? And that's your first step. Find a lower base that each of the given bases could be reduced to. So you want to do that. Find a lower base. Now in this case here, they're powers of 3. Okay? Sometimes they're powers of 2, powers of 5, or powers of 6. We don't tend to worry about too much more. But once that's done, we rewrite each of the larger bases. The larger base in terms of the smaller one. Okay? In this case, I'm going to rewrite them all in terms of 3. And the left side's already done, so that's good. And that's not always the way. Then you simplify using the exponent laws, and then you solve what's left. Sorry, I paused it there. My phone kept ringing, so I apologize. Nonetheless, once you get the common base, then you just solve what's left. Now I'm going to solve this one here just really quickly to show you what I mean. But nonetheless, you've got this one. So for example, e.g., okay, you've got this 3 to the power of x plus 1 equals 27 to the power of x. And you look at that and you say, okay, those are common powers. So what I'm going to do is I'm going to think, what is the lowest power for each of those? And the lowest power is 3, which means the left side's all set and good. It's ready to go. The right side is 27 to the power of x. Now I opened a big set of brackets because what I want to do is I need to think, what is 27 as a power of 3? And I go to my list, or I go to my calculator, try 3 squared, 3 cubed, 3 to the 4th, etc., etc. I know 27 is 3 cubed. Now, once I get 27 is 3 cubed, then I've got it in terms of a common base. So I'm going to use exponent laws on the complex side, this side here. The left still stays as 3 to the power of x plus 1. On the right, it's 3 to the power of 3 times x, okay, because it's power to a power. Multiply the exponents, keep the base the same. Once I've got it as a single exponent on each side, it has to be a single exponent on each side. That was step 3, way back up here. simplify to a single exponent, each having the same base. Once that's done, whatever the exponent is irrelevant. I can say, using logic, well, if 3 to the power of x plus 1 equals 3 to the power of 3x, then the x plus 1 on this side has to be 3x on the other. Whatever it is, those have to be the same. Then I use algebra, okay? Solving it over, I'm going to subtract the x. I'm going to get 2x on one side, divide by 2, I'm going to get x equals 1/2, and there is my solution. That's how this works. That's all that's going on. Okay? The key is remembering what the common base is. Okay? So e.g., here's another equation. 2 to the power of 4x minus 7 equals 8. Okay? I look at this guy and I say, okay, I need a common power. Now, the common power is 2. The left side, again, is already done. It's not going to stay that way, but the left side is already done, 4x minus 7. On the right side, it's 8. What is 8 as a power of 2? Well, that's 2 cubed. So once that's done, I get 2 to the power of 4x minus 7 equals 2 cubed. And once I've got a single exponent on each side with the same base, I can ignore the bases. I don't have to look at them, because I know that one side's exponent, 4x minus 7, has to equal the other side's exponent, 3. Using algebra, I add the 7 over, so I'll get 4x equals 10. Divide by 4, I will get x equals 10 quarters, or 5 halves, or 2.5. Okay? And so there's my solution, 2.5. Okay, or 5 halves, or 10 quarters, depending on how you do it. Okay? Okay? And so on and so forth. Okay? So once you get this idea down, that's all that's going on. And it just doesn't stay with only one side needing some adjustments. I could give you things like this. I could give you, and here this is going to be a fraction of some sort. It's not necessarily going to be nice, but I could give you 25 to the power of x plus 3 times 5 to the power of 2x plus 8 equals 125 to the power of 6x. Okay? And so on and so forth. Now this is complicated, but it's still an exponential function. And it's still an exponential function that I can get common powers of everything. So I'm looking at this side and I'm saying, well, 25, that's something in the terms of 5 to the power of x plus 3. Times, here I've got 5 to the 2x plus 8. And here I've got 125, or something, to the power of 6x. And I'm looking for my common power. My common power is 5. 25 is 5 squared. 125 is 5 cubed. So this gets nasty looking, but nonetheless the whole idea is the same. So I'm going to get 5 squared times this. Keep the base the same, 5. Multiply the exponents. 2 times x plus 3 is 2x plus 6. Here I get 5 to the power of 2x plus 8 equals, and here I'm going to get 5. 3 times 6x, 3 times 6x is going to be 18x. I'm not quite done. I've got all 5s, yes, but the left side isn't finished, so I'm going to keep the base the same and I add the exponents. 2x plus 2x is 4x, 6 plus 8 is 14, equals 5 to the power of 18x. Now that I've got a whole number on each side, a single exponent on each side, I can ignore them. So I'm going to get 4x plus 14 equals 18x. Using algebra, I solve. I'm going to take this 4x and move it over. So I'm going to get 14 on the left. 18 minus 4 is 14x. Divide by 14, I'm going to get x equals 1. There's my solution. Okay? And so on and so forth. That's all that's going on here. The only thing is it just gets more and more complicated as life goes on. But the same idea. Whatever's not a single exponent needs to be put together using exponent laws. And then once you have a single exponent, and I can't emphasize that enough, I'm going to write it right here. Single exponent on each side. I know it's right at the bottom. It has to be a single exponent on each side. If it isn't a single exponent on each side, you can't just cross out the exponents. But once you have a single exponent on each side, you can cross out the exponents. So that's the introduction, or that's what's going on in this lesson, and that's what we'll just do. Okay. Last but not least, you could have ones. Now this isn't going to be in the notes, but you could have ones like this. Dwight made an error in his solution. Where's the error? Okay. And so you can go through and take a look. Okay, well, we've got 25 to the power of x plus 3 equals 625 to the power of 2x plus 3. So you've got that. So you know they're going to be powers of 5. 25 is 5 squared. 625 is 5 to the 4th. So you can go through and say, okay, so it's going to be 5 squared times x plus 3, 5 to the 4th to the 2x to the 3. So that looks good. That step looks good. Now going here, you're going to multiply 2x plus 3 is 2x plus 6. Here, you're going to put 5 to the 4th to the 2x cubed. So 4 times 2x. He says that's 6x. That's supposed to be 8. There's his error in step 2. Okay? And so you can go through and take a look at the work. He gets 3/8, but it's because he made his mistake right here in step 2. Okay? So you can go through and do these. You're solving the equation. Basically, the hard part is you're looking at somebody else's work and you've got to follow along their thought process, because it may not be exactly the way you see it. Okay? But nonetheless, that's what boils down to. Okay? So, going with this idea, that's the homework, that's the lesson. If you have any questions, just ask, and otherwise, have a fantastic day.